Welcome to this pymol overview. Pymol is another molecular graphics tool, very sophisticated, but is based on the Python programming language. You can see that there's a set of tools over here that we'll use. Another set of tools here for display, controlling the display. We have a set of drop-down menus, and we have a Python prompt, and we can type Python commands just like we would within another one of our scripting tools. There's actually two Python command prompts, but they both give output in the same window on the top left, as you'll see. You notice this says for educational use only, but we can bring PDB files in a couple of different ways. We can get PDB is the first option from the file drop-down, and you can enter a 4-letter code. What am I going to bring over? We're going to stick with the HIV protease, I believe. So let's bring down 2Q5FK. That's HIV protease bound to a drug called lopinavir. And there it is. And you see that there's water molecules, so you can rotate and zoom with different, the right and left mouse buttons. The center button will allow you to clip through the molecule a little bit. And you can see you have your protein chains as with other tools, but you also have your water molecules and some other counter ions. And you have these set of display options for whatever happens to be selected. We'll go choose 2Q5K and unselect water or delete water molecules under the action button. And then under the show button, we'll choose cartoon, which is the standard ribbon diagram. And you can see that the ribbon diagram for pymol is a little different than the cartoon. We want the cartoon. So you can go to hide to get rid of the ribbons again. And you can draw that also as the sphere model, CPK rendering. And there you can see your color scheme is the standard color scheme with carbon as green. Now under the display, we can go to display the sequence, and we can either choose to display the designation of the chains or the designation of the single letter code. So we can see here if we click those that's a selection if we left click those, but in order to deselect we have to click again. So that allows you to select multiple items at once, and you see I selected all of the phosphates. And now I'm going to draw them, and you see there's a selection line on our display menu. So I'll choose selection, and I will. What can we do? We can remove them entirely, or we can extract them to a new object. Let's do that first. So now we see that we have a separate set of objects representing those phosphate ions, and I'll rename those. I'll rename them to delete, so we can get around to deleting them later. But for now, we can just go to the hide menu and hide everything, and they're gone. Now we can play around with selecting by clicking and unclicking the different objects in the protein and ligand object now. And now I've selected the ligand. You can see the pink squares appear. So I'll go to the selection item, and I can draw those as sticks. Right? So I'll choose stick representation. It's still selected, and I can change the color simply by going to the same line. Remember, it's called selection. Choose color, many options. I'll color by element, and you have a variety of options for carbon. So in this case, I'll make carbon white, whereas oxygens are red, nitrogens are blue. And you can see that I can rotate that around. But as I did with with the phosphates, I'll extract these as a separate object. You see object 01 comes up And now I'll rename that to, lopinavir. So that's our HIV protease inhibitor bound to the active site. Now, let's go ahead and delete those phosphates. Things are starting to get cluttered. And we can recenter. There we go. Delete the phosphates. Play around with your mouse tool to be able to translate the molecule. And now we can see too that we have two subunits, which I'll extract. The A subunit, let's rename that now. Chain A. And what remains, since I extracted it in the original object, is chain B, which you can see if you click. You'll see all the atoms selected if you click it. So now that I've selected it, I'll extract that. I'll call it chain B. So now the two individual chains in my protein, as well as the ligand, are all three individual objects. Yeah, good idea to always save your session as you go. Save it somewhere you know, somewhere that you keep track of with a name that you can interpret. Taking me a while to navigate to my location, but you'll see now that I'll call this pymol test 1. Lovely. You see my three objects. Lopinavir, chain A and chain B. I can color each of those individual chains. You have a whole variety of colors that you can select from. I'll choose slate. At the command line, you can define these in a much broader range of colors, but these defaults are sufficient for most work. And now you can see clearly that the two chains, A and B, of HIV protease are highly symmetrical. And look at their sequences; they're identical. We can select from chain A. So if let's pay attention to the fact that under the display menu we chose to display the sequence object instead of the chain object. Now I've selected both of the aspartic acids, aspartic acid 25 in both sequences, and I extract those to a new object, again renaming that new object, this time to active site. So those aspartates are the active site residues. Now you can see that I've selected those side chains, but they're not drawn. And so I must show them as sticks. And now they appear in the same color as the ribbons from which we derive them. And I'll also color them now by element. And you can see now, let's position it the way we would like. Oh, we will clip, but no, let's move in to take a closer look at the ligand, protease inhibitor, interacting directly with both the symmetrically placed aspartate side chains. All right, now I'm just going to start that again, showing you a different way to bring in the protein, this time using fetch at the command line. And just to sort of by way of repetition, deleting the waters. This time I'm selecting those phosphates manually, and I'm just going to, that selection, I'll just delete no, I didn't want to delete the selection, I want to delete the atoms. So select, go to actions for your selection, remove, just a little cleaner. Just repeating ourselves here so you can see we're displaying our chain identifiers once we click the S at the bottom. And now we see that we've got those three guys again. There they are. And what we did previously was all about extracting those guys and renaming them as individual objects. There's the ligand. Change its color. let's draw a surface. So since we only have one protein object that includes both chains, it encompasses the whole object, and that's colored by atom type. And at the command line, we can set our transparency to some intermediate value so that we can see through the surface to the ribbon diagram below. And we can change the color as we wish. That'll also change the color of the ribbon. Undo, not always behaving in this case. All right, so make sure we're coloring the right option, the right item, not the ligand here, but the protein. Color it slate. That's lovely. Yes? So now we see the solvent accessible surface area of that protein. Let's go back to our display and choose residue codes again. Now we see the amino acids. And since I haven't separated the objects, both sequences of A and B appear in the same line. And I'll go back and select that aspartic acid 25, D25. Now that's our selection. And under the action for the selection, remember, we'll copy to a new object. That'll be an interesting variation now. And we'll rename that object. Right, so if we copy to a new object as opposed to extract, if we extract, we'll take those amino acids out of the original structure. So we want to avoid that. We want to display those guys separately from the ribbon diagram. So now we have an active site that we can color separately without damaging the original structure. So we see now we were back at the same place we were previously, but with the addition of a surface representation. So let's notice that we have our aspartic acids highlighted, standard color scheme. We have all of our objects, the protein, the ligand, the active site. We can hide everything. And we can bring back individual chains. Now these aren't named properly, so let me go back and rename those. So this will be chain A, and then object 1 here. That's right, that will rename chain B. If I can spell. So now our object list gives us a very clear sense of the tools we have to play with. There we go. Chain A is drawn. We'll draw it, let's make it chartreuse. So now that we see those two symmetrically arranged monomers in different colors, we'll draw our side chains object, and we'll draw our ligand object also as sticks. Chain B, let's add a surface. Beauty. Chain A, let's add a surface. The reason we want to do this for individual chains is that the surface is contiguous and separate colors. That can be pretty powerful. Now we can recenter, orient it the way we like. So if we undisplay one of the monomers in one way or the other, we'll be able to see the contiguous surface of the other without disruption. So we're going to right-click and drag object matrix. And if you hold down the Shift button, here you can read about your three button editing options. We can hold down the shift button, try different mouse buttons to see that you can rotate it and completely pull it away by selecting drag matrix. Completely pull it away, and you can then get a sense of the intimacy with which those two units are interacting. But we can also undo that by let's find that option. No, not in our main pop-up menu. It's in our action menu. Chain A, reset matrix, and it pops back into position. We can also just take that molecule away entirely and see the interface of the two subunits, as well as how they interact symmetrically with the ligand as well. But if you hide it, you have to go through both steps of bringing the entire thing back. Okay, so I'll get rid of everything again, and now we're back to where we were before. A nice clear view of the protein. I'm going to remove the ligand as well. And what I'm setting us up for here is the creation of a movie. So I'll set up several scenes. We go to the scene menu, choose your initial scene, just the ribbon representation as F1. And now I can add everything else back. So the first thing I'll add back for my next scene would be the ligand, which I'll draw as sticks. There it is. That's scene, store, F2. So now I have 2 keyframes for our movie. The third thing will be to add the active site back. Keyframe 3. No, not append. Maybe I'm not ready. Okay, so before I create that as a scene, we'll zoom in. So our third keyframe will include ligand and side chains and cartoon structure of the protein, and that will be frame 3. Oops, and if you get confused, in the lower left you'll see F3. Now you'll see that I have F3 and F4. In the lower left, I can see my different frames. I'll fix that in a moment. You can play around with positioning. I'll zoom back out for the 4th frame, and I will add my surfaces back. So now I have my surfaces for the protein chains. And I'll store that as F4. But now my F3 and F4 are a little bit out of order, so you can scan through them. F3, F4, and then F3. F3. So you can see that how the scenes are going to transition from one to the other, smooth transitions between them. Yeah, I think I'm going to have to reset my frames. So I'll clear a frame. I'll clear F4, and now I see F1, F2 with the ligands, F3 zoomed in on the active site, and now I'll go back and reset my surfaces one more time. You can see with right click you have some zoom options that appear, but let's go back to A and add the surface, and B, and B and add the surface, and now that's looking like frame 4. So scene, store, F4. Now you see that through the magic of movie editing, I'll add a 5th frame here. So I've reorganized my keyframes a little bit to make the movie, but for our purposes it doesn't really matter. Just note that you can create an important set of keyframes that then you're going to use to make your movie. So here we go. Select keyframe 1, we're going to go to the movie program menu and add a Y roll of 4 seconds. That's going to cause, and you'll see now the scrubber appears at the bottom of the screen, and you'll see that you can have a hard time grabbing the scrubber for some reason. You can also just push play. For whatever reason, I'm having a tough time here. Eventually, we'll get the scrubber. And now we can see that the first 4 seconds of the movie are simply a rotation. I'll move to the end, and then I'll append a 2 seconds of nothing, no action. And so we go through our rotation, and we have 2 seconds, and then I'll stop it there. And a little ways into that, I'll right-click Store with Scene, and choose the next keyframe. And now you'll see that the next frame, and I'll immediately append a second to that, and we should see that the ligand appears and appears for a second or so, and then it'll disappear. All right, so we're back there. We'll pull back our scrubber a little bit, right click, Store with Scene 3, and so in this case that's a zoom in, and we'll immediately append 2 seconds to that. So now all we've done is zoom in here, right? We're zooming in, and then we're back. Okay, so somewhere there we'll switch to keyframe 3, which keyframe 4, that is keyframe 4, I believe. Where do we want to? So you have to make these calls. Move your scrubber to the place you want to add your next transition. I'll add it here. Store with Scene 4, which are my active site. I'm going to append a couple of seconds. Again, that gives me some room to play with where I set my next transition. So I'm rapidly cycling through those keyframes here. And now I'm going to add another camera loop. And you can play with the other options here. Let's move it back. I'd like to not have to zoom in and out like that, but in any case, we can now program a Y roll of the camera, a couple of seconds, and then we see we're entering the Y roll, right? And then we're at the end of the movie, so right there, we're gonna store with scene and add our final scene, which just adds the surface representation. We'll immediately append couple seconds just so you can where'd that go? Oh yeah. Yeah, it's a little annoying. Sometimes there's a little bit difficult placement of where you place those, but now I'll try again to append a couple of seconds of sphere. No, still not there. Store with scene, tell it again, storing with scene 5, append a few seconds. It's really being a pain. Let's watch Blake struggle with getting. Okay, so let's instead of trying to append there, let's do another Y roll, and now we see that we have a Y roll added to the end. It's a little annoying because I don't think I placed my Y roll exactly where I wanted it to be, but that's okay. We can push play and see what happens. We go through a rotation of the ribbon diagram. We add back our ligand and active site and zoom in, zoom out slowly, Ken Burns effect, rotation of the active site, addition, oops, see, that was a little clumsy. Zooming back out, addition of the surface, followed by rotation through that surface. A little clumsy, but you get the idea. You can play around more with making your own movie. And of course, you're going to file, export the movie as an MPEG, and you can save it as a couple of different methods of rendering, either fast or ray drawing. I invite you to try both. You'll notice that the fast is obviously faster and smaller size file than the ray tracing. Play with those, see which ones you like best.